we're going to take a look at some series that look like we know what the behavior is, but unfortunately, we have to be able to compare them to a series that we know what the behavior does. So we're going to use these two tests called comparison and limit comparison tests. The comparison test is a little bit easier to implement because it doesn't require a lot of high-level sort of calculations, but it doesn't always work. Okay, it only works if the compared series meets some sort of conditions, which we'll go through in a few moments. The limit comparison test does work for almost all the time, but it's a little bit more rigorous algebraically. Okay, so let's start off with the comparison test. And what we're going to do is we're going to take a series that it looks like a series that we've seen before and we know the behavior of. And we're just going to compare the behavior of the series that we really want to determine whether it converges or diverges to the behavior of something that we think converges or diverges. So for instance, if we had this series, the series 1 over n cubed plus 1, well, as n approaches infinity, this 1 really doesn't contribute anything to the sum compared to the infinity. And so what we would do is we would just look at this dominant term right here. Okay, so the dominant term is going to be basically going to be the term that grows the quickest. And what we do is we would just compare it to 1 over n cubed. And that's a series we know what to do with. We can either use an integral test or a p-series test or something like that. So let's say, for instance, that we know a series to compare it to. If the original sequence is smaller than the sequence that we're comparing it to, and the compared series converges, that means that the original series converges as well. And that makes sense to us because if we know that the terms in the unknown series are going to add up to be terms that are smaller, and a sum that's going to be smaller than the compared series, then they both should have the same behavior. All right, if the bigger one converges, the smaller one has to converge as well. Now, let's say that the compared sequence terms are getting bigger than the original one. Then what we're going to do is we're just going to say, okay, well, if b sub n diverges, in other words, the compared series, which is smaller than the original series, that means that the original series will diverge. All right, and the way I'm going to do this is I'm just going to start listing out a few terms in each of the sequences, the compared and the original, and see whether or not they're getting smaller or larger. Then I'm going to determine the behavior of the compared series. Okay, so first thing we're going to do is we're going to figure out some compared series. Okay, so find your series b sub n, the compared series, right? After that, then you're going to see, does a sub n, or not does, but is a sub n, the terms in sequence a sub n less than or equal to b sub n, or is a sub n, or is b sub n less than or equal to a sub n? Okay. And then finally, you're going to find the behavior of b sub n. Okay, so those are the 3 steps for our comparison test. So let's start off with an example that's not too bad. So we have the series n equals 2 to infinity 1 over n cubed plus 15. First thing we do is we take a look at the numerator and the denominator, and we try to identify the dominant terms. Okay, so the only thing that we really have to worry about is this n cubed. So what I'm going to do is I'm going to compare this to the series n equals 2 to infinity of 1 over n cubed. All right, so again, I really don't care too much about that 15 and that 2 in the denominator. Okay, because as n goes towards infinity, they really don't matter too much. Right, now this is going to be b sub n, the compared series. This is going to be a sub n, the original series. Right, so the next thing we're going to do is we're going to determine what's the terms in the sequence compared to one another. Right, so I'm just going to make a table of values. All right, so I'm going to have n, and remember, n starts at 2. All right, and I'll just do like maybe the first four terms. And then we're going to have a sub n, okay, which is going to be 1 over 2n cubed plus 15. And then I'm going to have b sub n, which is 1 over n cubed. Now notice I'm not trying to look for the terms in this to add up the series. I'm just looking at the terms in the sequence. Okay, so if I plug 2 back in here, okay, that's going to be 1 over 2 times 8, which is 16. 16 plus 15 is going to give us 31. So this becomes 1 over 31. If I plug 3 in, okay, and I might need a calculator to do this just efficiently. So that's going to be 2 times 27 plus 15. So I get 1 over 69. And of course, I could use like Excel, but on an examination, you won't have Excel. So I'm just using this method. Substituting 4 back in, this is going to be 4 times 64, or 2 times 64, plus 15. So that's 1 over 143. And then finally, if I throw 5 back in there, that's going to be 2 times 125 plus 15. So that's 1 over 265. All right, now, if I throw 2, 3, 4, 5 back in to b sub n, this is going to be 1 over 8. This is going to be 1 over 27. This is 1 over 64 and 1 over 125. And clearly, all of these terms are smaller, all right, for a sub n. So it looks like to me that a sub n is less than or equal to b sub n, okay? And so if we go back up to the rules, a sub n is less than b sub n, then we're trying to determine if b sub n converges, okay? So let's take a, so this is part I, and then for part II, okay, we have the series n equals 2 to infinity of 1 over n cubed. All right, well, that is a p series. Okay, so remember from the last video series that this is going to be a p series with p equal 3, which is clearly greater than 1. So this converges. Okay, and because it converges and a sub n is less than b sub n, at least for some small values, but we could extrapolate that it's going to. So we could say, hence, by I and II, the original series, which was n equals 2 to infinity, 1 over 2n cubed plus 15, converges as well. And I'm probably going to have to fit that in there a little bit better. So sorry about that. But this does converge. Okay. All right. So again, when you're doing these problems, the first thing you want to do is you want to determine a series that's comparable. Okay. Next thing you want to do is you want to go through, compare the terms in the series to see if they're getting smaller or bigger. And then finally, determine the behavior of the compared series. Okay. And if all the conditions line up, which they do, okay, so a sub n was less than or equal to b sub n terms, and then the series that we were comparing to converges, then a sub n converges as well. All right, so in subsequent videos, we're going to take a look at 2 more examples of the comparison test, okay? And you can see there's not really that much other than some computation and then some really basic analysis of using the series test that we already know.